Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 60, and this problem tells us that we have a monomer that's used to form a polymer that's used for plastic sheeting and soft drink bottles, and it has a strong IR spectra at 1692, and it has two NMR signals, HNMR signals, one at 8.2 ppm and one at 10 ppm. What is the structure given the molecular formula of C8H6O4? So in order to determine the structure of this monomer, what we need to do is first determine the number of double bonds or degree of unsaturation. Number of double bonds or degree of unsaturation would equal to number of carbons, being 8, minus the number of halides and hydrogens over 2, so 6 over 2, minus the number of nitrogens over 2, 0 over 2, plus 1. So 8 minus 3 equals 5, plus 1 equals 6. So now we have also an IR spectra or IR peak at 1692, which corresponds to a carbonyl bond. And then we have NMR, two NMR singlets, one at 8, one at 10. So let's try to figure out what this could be. Well, right away, we can say that the singlet at 8 is going to represent aromatic protons. So we know 7 to 8 is typically your aromatic protons, so we can draw those aromatic protons right off the bat. So that's 1 degree of unsaturation, 2, 3, 4 degrees unsaturation. So now we have 2 more to figure out where they are. And because there's only one type of proton, we know that there's going to be an internal plane of symmetry. So what happens on one side is going to happen on the other side. So let's see, how many more carbons do we need? We need 2 more carbons, so I satisfied that. We have 4 oxygens, we have a carbonyl bond, and we have 2 degrees of saturation. So let's say we add those carbonyl bonds on each side. So that's 1 degree of saturation, and that's 2 degrees of saturation. So now we have no more degrees of saturation to worry about, but now we still have 2 oxygens and 2 hydrogens left. And we also have a ppm at 10. So the only way that we can have a singlet is if these are bound to oxygens and the oxygens are bound to those protons. And it makes sense because those protons would be very de-shielded, so they would have a very high ppm value as indicated here. And because of that internal plane of symmetry, you only see that, or even this way is internal plane of symmetry, you only see that one type of proton occurring for your aromatic ring and for your carboxylic acid ring. So just by rationally thinking and going through the process of what we know and what we don't know, we were able to determine the structure of this molecule.